After Elon Musk's cryptic tweet just left the Tesla design studio, there will be an epic and shocking demonstration by the end of this year. Speculation has grown rapidly. Several sources suggest that the new version has been trained to perform over 500 additional tasks, ranging from manufacturing and logistics to home assistance. So, is Optimus now ready to take on real-world jobs, and if so, what might that actually look like? Before we begin, please help us reach 12,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How is Optimus 2.5 different from Tesla's previous robot versions? When Elon Musk declared, "That's Optimus 2.5, he wasn't merely naming a new robot version. He was signaling a clear milestone in Tesla's humanoid robot development. The use of 2.5 implies that Tesla is positioned between two major stages, having just moved past the technical testing phase of Gen 2 and nearing the commercialization target of Gen 3. In Tesla's product ecosystem, versions marked with .5 often indicate experimental intermediates that are stable enough for large-scale real-world testing. This approach was previously seen with Starship prototypes from SN5 to SN15 and temporary development phases of the Model S Plaid Plus. With Optimus 2.5, Elon Musk is implicitly confirming that Tesla has built a robot stable enough for real-world production environments, though not yet meeting the human-like benchmark he envisions for Gen 3. Specifically, Optimus 2.5 was introduced with several impressive specifications: a weight of just 110 pounds, lighter than Figure 01 at 150 pounds, and Boston Dynamics Atlas at over 176 pounds. It includes 28 actuators entirely developed by Tesla, enabling smoother movements in joints such as arms, legs, neck, hips, and fingers. The robot can walk bipedally, maintain balance in place, rotate, step forward, and perform basic tasks like picking up small objects, sorting, and folding. Most notably, Tesla has integrated the FSD processor, originally designed for autonomous driving, into Optimus's central control system. This dramatically improves reaction speed, real-time data processing, and intelligent motion learning. The robot's response latency for some basic tasks is reported to be under 10 milliseconds, a rarity among current commercial humanoid robots. However, the decision not to label this version as Optimus Gen 3 reflects Tesla's strategic caution. According to Elon Musk, the ultimate goal is a robot with agility roughly equal to an agile human, meaning it must move, react, and adapt as flexibly as a swift person. This requires not only walking but also climbing stairs, smoothly avoiding obstacles, handling unexpected situations, and even standing back up after a fall. Meeting these demands requires extremely low reaction times, around 300 milliseconds, advanced dynamic prediction, and precise force control with the environment, none of which current commercial robots have fully achieved. Even Boston Dynamics, whose Atlas demonstrates impressive jumping and climbing routines, has yet to commercialize it widely or enable real-time AI autonomy in the way Tesla intends. Thus, pausing at Optimus 2.5 is a wise move. Rather than rushing to Gen 3 with high expectations and high risks, Tesla is opting for broad internal testing with version 2.5. This is a learn-by-doing strategy, deploying Optimus 2.5 across its factories to perform real tasks while collecting data to train the AI and refine the hardware based on real-world feedback. It also allows Tesla to establish its mass production process early. According to official statements, the company plans to build the first 10,000 Optimus units at Giga, Texas, the same site that produces the Model Y and Cybertruck. This means Tesla is not only building robots, but also building the robot assembly lines, something rare in today's robotics industry. In addition to technical and strategic benefits, Optimus 2.5 delivers a major communication impact. While competitors like Figure AI or 1X are still showcasing prototypes, Tesla is already deploying thousands of robots internally and preparing for large-scale production. This sends a clear message that Tesla is leading, not just in technology, but in execution speed and commercialization readiness. With full control over its supply chain, from software and AI chips to manufacturing plants, Tesla holds an unmatched advantage. This reinforces investor confidence in the company's robot ambitions. Elon Musk has emphasized that the economic value of Optimus could surpass that of electric vehicles, since most jobs globally are still manual labor, an area robots could largely replace if designed to be intelligent, affordable, and durable enough. In summary, Optimus 2.5 represents a pivotal upgrade, not just in technology but in deployment strategy. It is the bridge between R&D and large-scale production. Through real-world testing, AI training with real data, and simultaneous factory build-out, Tesla is laying a solid foundation for Gen 3, where humanoid robots will not only move like real humans, but also be ready for market launch at a shocking price point under $20,000. As the entire humanoid robot industry still struggles with prototypes and high costs, Optimus 2.5 positions Tesla as the front-runner in the next-generation automation revolution. Once again, please help us reach 12,000 subscribers. This is important for us to stay motivated. Thank you. Why does Elon Musk believe Tesla can build a Gen 3 robot with human-level agility? One of Elon Musk's most attention-grabbing statements recently was his assertion that the upcoming Optimus Gen 3 will possess agility roughly equal to an agile human, a phrase that can be understood as having flexibility equivalent to a healthy and nimble person. This is not just an ambitious technical target, it marks a clear dividing line between basic assistive robots and robots truly capable of replacing humans in tasks requiring quick reflexes, flexible problem-solving, and sustained operation in dynamic environments. By deliberately emphasizing the word agile instead of strong or intelligent, Musk signaled that Tesla has moved past the stage of focusing solely on mechanical strength, and is now tackling a far more complex challenge, combining speed, precision, flexibility, and stability into a single robotic system. Agility in robotics is not merely the ability to perform fast movements. It requires the ability to predict the next motion, shift body posture in an instant, and react to unpredictable environments. In the robotics world, this represents one of the highest hurdles. For example, when a person suddenly encounters a slippery surface or an obstacle ahead, the brain processes a flood of sensory inputs, balance, pressure, traction, and immediately decides how to adjust, lean the body, lengthen the stride, twist the waist, or bend the knees. All of this happens within a few hundred milliseconds. A robot aiming for similar agility must have high-resolution real-time perception, powerful neural processing to interpret the situation instantly. From a technical standpoint, achieving this level of agility demands seamless integration of three core systems: force, vision, and inertial sensors. Extremely fast deep learning processors and actuators capable of immediate response across wide ranges of motion. On a humanoid robot, especially a biped like Optimus, this challenge becomes even more intense, as everything must operate within limited space, energy, and material durability. For a robot to sidestep a falling object, step back when nudged, or dodge when someone walks in front of it, it needs an AI system capable of real-time motion prediction, trained on millions of real-world scenarios. This also means Gen 3 can't simply be assembled and run. It must be equipped with a deeply trained AI system at a level far beyond what autonomous vehicles require. Tesla holds a unique advantage in this field. Its massive AI infrastructure already supports autopilot and FSD across millions of cars. The Dojo supercomputer, Tesla's in-house design, is also being used to train the neural networks powering the Optimus robot. The major difference is that instead of merely learning to detect lane markings or nearby cars, a humanoid robot must learn millions of human poses, understand how to behave in physical interactions, and adjust its applied force in changing environments such as slippery floors, sloped surfaces, or extreme temperatures. This is why Tesla continues to let its robots practice in real-world settings, something no other robotics company in the world is currently doing at this scale. Beyond software, achieving human-like agility also requires hardware breakthroughs. While the current Optimus Gen 2.5 still relies on a mechanical skeleton with limited feedback and some joints that have speed constraints, Gen 3 may adopt new materials with higher elasticity or actuators with real-time torque sensing. Tesla has previously stated that it is developing a fully Tesla-designed actuator system and continues to improve it to reduce weight, increase responsiveness, and enhance joint precision. These advancements are critical if Optimus is to enter fields like healthcare, elderly assistance, high-speed manufacturing, or any human-facing environment, where even small mistakes can have serious consequences. Another crucial factor is that agility does not come from hardware alone, but also from coordination among body parts. An agile person knows how to rotate using their waist, shift their center of gravity, and redistribute body weight optimally while running, jumping, or changing direction. This requires continuous multi-axis coordination, a massive challenge for bipedal robots. Optimus Gen 3 must learn these movement patterns like an athlete, not only maintaining balance but optimizing posture and kinetic energy through every motion phase. If successful, Tesla won't just create a robot that can work, but a humanoid capable of integrating seamlessly into human environments without appearing robotic, stiff, or awkward. Most importantly, the goal of agility equal to an agile human represents Tesla's long-term strategic vision, putting robots into spaces where only humans have previously been effective: hospitals, nursing homes, restaurants, hotels, and even private homes. It signals that Tesla isn't just building robots for heavy industry, but aims to create multi-purpose, socially capable robots that operate long-term in human-centered settings. Once Optimus can move as flexibly as a person, it will overcome the biggest barrier humanoid robots have ever faced: the ability to interact naturally with unstructured environments where there are no predefined scripts, no lane markings, and no physical guides like in factories or parking lots. Tesla's ambition to bring Optimus Gen 3 into the real world isn't just about AI or robotics. It's also a manufacturing challenge on an unprecedented scale. Elon Musk has confirmed that production of Optimus is already underway at Giga Texas, with a plan to build the first 10,000 units. Unlike traditional robotics companies that treat each robot as a handcrafted prototype, Tesla approaches robot production like it does with electric vehicles: full vertical integration, heavy automation, and continuous design iteration. One of the biggest breakthroughs in Tesla's manufacturing strategy is its ability to co-develop the product and the production line simultaneously. As Optimus 2.5 is being deployed internally in Tesla's factories, engineers are collecting real-world usage data, optimizing hardware based on failures and feedback, and refining the assembly process in parallel. This build-while-learning approach significantly shortens development cycles and ensures that when Gen 3 is ready, Tesla already has a proven, scalable production line. The use of shared components between Optimus and Tesla's EVs, such as actuators, sensors, and the FSD chip, also drastically reduces part complexity and cost. Combined with Tesla's expertise in gigacasting and large-scale battery module production, this allows the robot to be built at a fraction of the cost typical in the robotics industry. Musk's bold claim of a sub-$20,000 price point for Optimus hinges on this exact advantage. Moreover, Tesla is leveraging its experience with software-defined manufacturing, where firmware updates and robot calibration happen digitally on the factory floor. This makes each unit smarter over time, even post-deployment. In short, Tesla isn't just building a robot, it's building a robot factory, which may ultimately become its most disruptive innovation. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.